All right, happy Friday, class. Unfortunately, I will not be able to join you guys today. But if we decided that we were going to play basketball this afternoon at Moody Park, I will still see you there. I'll be there about 4:30. Okay. But I still wanted to push on with our content. Today we're going to be talking about something called feedback loops. Okay. So a loop is basically a cycle, and we're going to talk about our feedback loops. All right. There are a couple warm-up questions for you, and I need basically a volunteer to pause this video whenever I say pause or whenever I give you guys a time limit to work on that material, okay? So I need a volunteer to pause this video, and I want you guys working on your warm-ups, all right? So you may go ahead, get started, read what we got up here, and go. You've got the first 5 minutes of class to do this, all right? Someone go ahead and pause me. Okay, so now that I am unpaused, okay, you should have talked about, you're running this track meet, you need some carbohydrates, what 2 body systems you're going to use. If you guys said digestive system, because you're going to break down those carbohydrates into ATP and energy, and then later use it in your muscular system, those are 2 great answers, and there's quite a few other answers, but I'm not going to go into those. If you looked at these 2 pictures and you saw this track star over here and you saw this grandma who's asking, does shivering count as exercise? Yeah. Basically, you're comparing those 2 images and you're supposed to compare how your body is reacting or responding differently in each of those situations. Which definitely leads us to System 16. Okay, so let's go ahead and get System 16 out. Let's go ahead and write our names on there just to make sure that when you turn it in, I have something to attach a name to, all right? And today is a P day for all classes, so whether you're 1P, 3P, or 4P, go ahead and write that down. So again, feedback loops, okay? Basically, there's something going on that's promoting a response. So that something that's promoting a response is called a stimulus. And our first example is going to be thermo, which means heat. And regulation, you guys probably heard that word before. Regulation just means something like balance or control, okay? So we're trying to balance or control our body temperature. Thermoregulation, again, control body temperature. Now we're going to be taking a few notes, but I also want you guys to give you guys an opportunity to try those notes before I even talk about them, okay? Basically, I'm going to tell you guys to start off over here. There's something called homeostasis, which is like your normal conditions. And your normal body temperature lies somewhere between 35.6 degrees Celsius and 37.8 degrees Celsius, which is about 94 degrees Fahrenheit. Okay? So if your body gets too hot, what are 2 ways that your body gets too hot? And what do you think is going to happen in that feedback loop? Okay? I want you to do that first. So I'm going to give you 3 minutes to try to figure out what words you're going to use in that word bank over there to help you with this problem, okay? So 3 minutes. Someone go ahead and pause me. All right, so now that our 3 minutes are up, let's go ahead and go over those answers, okay? So if our body gets too hot, there's a couple of ways that could happen. One is that there's just hot temperatures outside, okay? Summer is just around the corner. We still have to jump over spring break, but we're almost there. So if we have hot temperatures, that's definitely going to increase our body heat. And then also if we're running around exercising, that's also going to increase our body heat. That's going to activate the heat loss center in our hypothalamus. Now our hypothalamus is just this little gland over here in our brain, so it's part of our nervous system. But since it's also a gland, it's also part of our endocrine system, okay? So that's our hypothalamus. Our hypothalamus tells our blood vessels, hey, what I need you guys to do is expand. I need you guys to get bigger. I need you guys, and this might be a new word for quite a few of you, to dilate, okay? That word dilation just means to get bigger. So have you ever been really embarrassed and your cheeks started to blush and you felt like, wow, my cheeks feel really hot, my face feels really hot, right? So besides your cheeks blushing, turning pink or red, that heat is also leaving from the skin surface. So when you feel that heat sensation on your cheeks, that's exactly what's happening. It's because your blood vessels that are normally constricted are starting to expand to release that heat. Now, that's one response Another response that our heat loss sensor in the hypothalamus promotes is to activate your sweat glands. Now, when you activate your sweat glands, you're releasing water onto the surface of your skin. Now, that water, when it's exposed to the sun, is eventually going to evaporate, okay? And when it does, it starts to cool off your body, okay? Which kind of gives away the next blank. If we were too hot before, if we were exposed to hot temperatures or we were exercising, of course what we want to do is to decrease our body temperature. That's going to be the goal. So the stimulus, we were too hot. The response, we want to decrease that body temperature, okay? So we just did when our body gets too hot, and I'm going to give you guys 3 minutes for when your body gets too cold, okay? So someone come up here and go ahead and pause me, please. Okay, so now our body's too cold, and one reason that might be is because the temperatures are too cold. So we have cold temperatures. And another reason is where you might just be soaking wet, okay? Those elephants that live out there in the savannah and it's nice and hot and sunny, well, they go to the watering hole to cool off, right? That's one thing that they could do. But then their body also has different ways to kind of regulate that, and our bodies have those similar ways as well. So we had the heat loss center in the hypothalamus. Well, we also have the heat promoting center in the hypothalamus. And just like how the heat loss center told our blood vessels, hey, I need you to expand, I need you to dilate, okay? Our heat promoting center, if it's too cold, we don't want to release that much heat. So our blood vessels start to constrict. They get smaller. And when they do that, they're less likely to lose heat, all right? That's going to be one response of our heat promoting center. Our other response, I don't know if you guys recognize that tissue right there, but that's actually muscle tissue. Now, when you guys are cold, like you guys are probably going to be later today, right? Because the temperature is going to drop. Your muscles start to do something very funny. They start to shiver, okay? When you're in the cold and you start to shiver, what your body is basically doing is trying to generate heat so you don't freeze your butt off, right? So again, our stimulus was that our body was too cold, and now our response is that we're trying to increase body temperature. So our body temperature increases, and that's when it tells our heat gain center to shut off. It's like, oh, okay, guy, you've done your job. All right, so I'm going to give you guys a few moments to write that down, but I also want you guys to get the bottom portion of System 16, okay? So again, a few moments to make sure you have your notes. Someone go ahead and pause me for about 1 minute, and then we'll finish up System 16 front page. All right, so we're almost home free with System 16 front page. So let's go ahead and scroll down, or I'm going to scroll down. You guys actually have hard copy. So let's go ahead and move down to the bottom part. All right. Now I need to erase something over here. Let's see, where's my mouse? There it is. Okay, so thermoregulation is going to be an example of a negative feedback loop. And basically, a negative feedback loop is kind of like your seesaw, okay? So if you have a seesaw with one fat kid on one side and a super skinny kid on the other side, it's going to be imbalanced. So our negative feedback loops, and it looks like there's a typo here, negative feedback loops, okay? Basically, what you're trying to do is you're trying to get rebalanced, okay? So you're off kilter right now, you're trying to level things off, okay? So there's a stimulus, basically, that's occurring. And that stimulus promotes a response. And that response then acts to inhibit the stimulus. And thermoregulation is a perfect example of that. If we start to get too hot, we start to sweat, our blood vessels dilate so that we start to cool down. We're trying to rebalance, okay? If we're too cold, our blood vessels constrict, keeping in more heat. We start to shiver, increasing our body temperature, and again, we're trying to rebalance. Those are both negative feedback loops. Positive feedback loops tend to be a little bit more challenging for most students. In positive feedback loops, basically what's occurring is that you're having some sort of like a vicious cycle, okay? You have a stimulus. Okay. Oh, and I totally misspelled stimulus up there. So I put stimulates, okay? You need to change that to stimulus, all right? So there's a stimulus, which then promotes a response. And that response, instead of inhibiting or trying to shut down that stimulus, it in fact enhances it. Okay. That's in a positive feedback loop. So for me, one example that I thought of when I was thinking of positive feedback loops was actually one of my favorite childhood films. Okay, so you might recognize this scene. We got Simba over here, and we got a bunch of wildebeest, a whole herd of wildebeest that are running around. So you might be asking, Mr. T, I don't understand how this relates to positive feedback loops. Well, if you think about it, if you have a certain number of wildebeest that are running around. Wildebeest spelled W-I-L-D-E. Beasts. Okay. Running. They start to panic when they start running. If they see one wildebeest running, then the other guy's like, I don't know why he's running, but I'm going to start running too, because there must be danger. So when wildebeest start running, the panic level increases. And when you have more wildebeest freaking out, guess what's going to happen? You're going to have more wildebeest running around as well. So if you have more wildebeest running around, what's going to happen? Well, your panic levels is going to increase. And if your panic level increases, you're going to have more wildebeest running. And so that's where you have that positive feedback loop. It's basically going to be a vicious cycle. Okay? So another example, another biological example, would be blood clotting. Basically, every time you get a cut, blood clotting, C-L-O-T-T-I-N-G. So every time you get a cut, your little platelets start to clot it. And when it starts to do that, it almost like builds a dam, like a reservoir of these platelets that prevents your blood from leaking out so you don't bleed to death. All right? Another one is going to be oxytocin, which is going to be a hormone. And this hormone, basically what it does is, hold on one second, this hormone is basically going to stimulate the contractions of childbirth. So if you've ever seen those movies where a woman is giving birth, basically that oxytocin is being released, and it's like, okay, let me do more contractions. And every time it senses those contractions, it releases more oxytocin so that you get even more contractions. So eventually you push that baby out. Okay? So what I want you guys to do now is finish the backside of System 16. All right? So there's a whole backside for you guys to do. And if you finish your work early, then I want you to check your binder, check grade speed, see if there's anything that you need to make up or any grades that you can improve, and I want you to turn it into the bin, okay? Turn it into the bin, all right? I'll see you guys on Tuesday. Have a great day.